Well, hi, everybody. My name is Heidi Yoon. I'm an atmospheric chemist by training, and as part of the Earth Lab data analytics program, I've been investigating the vegetation recovery after the chimney tops to fire with Dr. Nayani Ilankun from Earth Lab. And we're interested in the chimney tops to fire because it's an example of a fire that was contained, but it escaped its containment zone. So in one day, the fire burned from Chimney Tops Mountain in the south all the way to Gatlinburg, Tennessee, because of unseasonable high winds and dry conditions. Wildfires such as these have been more frequent and more intense, and severity of the burned area has been identified as a property that can help us understand the recovery and if the fire can happen again. We have two goals for our workflow. First, we'd like to measure the vegetation recovery remotely with reflectance data. Measuring the forest recovery on the ground is extremely time and labor intensive, and remote sensing measurements allow us to determine the recovery from the air or from space and help us to cover more land area and measure more frequently. So we'll do this with NEON and Landsat 8 reflectance data. Our second goal is to use reflectance spectra and field data for the ground cover to identify vegetation and other components like standing dead trees and soil in the burned area at a sub-pixel level. For this talk, we'll consider one area within the fire boundary. So here's a map of the chimney tops to fire, and here's an RGB image of the area that we're going to be studying. So first, we've calculated the normalized difference vegetation index, or NDVI, post minus pre-fire. On the left, we've done this with NEON reflectance data, and on the right, with Landsat data. This shows where there's been regrowth in green and loss of vegetation in pink. We find that the difference in NDVI for Landsat data suggests more regrowth than for the NEON data. Another way to look at this another way to see this is to look at the histograms and box plots of the data distributions. So again, you can see that the Landsat data is shifted more towards positive difference NDVI, towards regrowth, than the NEON data. Next, we consider a plot within our area of interest, which is NEON plot 55, shown here in our RGB image with this pink box. And here's our diagram of plot 55 with its 8 well-defined subplots. So for each of our subplots, we've been able to obtain the reflectance spectrum for its coordinates and pair it with the percent cover from the NEON field data available. We find spectral differences with different concentrations of litter, soil, standing dead trees, and vegetation. So in this project, we've been able to characterize the recovery with vegetation indices using NEON and Landsat reflectance data, and we've been able to obtain reflectance spectra for subplots within the fire boundary and pair them with percent ground coverage. Next, we'd like to continue this project to build the spectral library with more reflectance spectra and percent cover field data in order to conduct a spectral band analysis and analyze the reflectance at a sub-pixel level. By doing so, we'll be able to show how we can analyze the vegetation recovery and determine the burn severity remotely. Lastly, I'd like to acknowledge all the support and guidance from Nayani on this project, and Eric, who I started this project with and learned a lot about wildfires. Also, I'd like to thank Elsa and Nate for their help in troubleshooting my code or to give me ideas on what to try next. And lastly, I'd like to thank everyone in my cohort who helped me make this project better with all their feedback. Thanks, everyone. Happy to answer any questions.